Picking up where we left off in the previous video, so we've got F, we've got G. Let's get straight into 5.3. So they're asking for A and B, okay? So A and B are our x-intercepts of our parabola. So this is the parabola, the f of x. So we're going to say that x, in order to find x-intercept, right? So let's say x-intercepts, and you know y has to equal to 0. So what is y? This whole thing is y. So we're going to say 0 is equal to x squared minus 2x minus our 3. How do you solve for x here? Let's go and factorize this. This is easy enough to factorize. And again, if you can't factorize, that's fine. Go use the quadratic formula. Use it as many times as you want. This factorization is nice and easy, right? 3 is prime. Those are our only options. So here, this minus 3 is equal to 0, and we're going to add 3 on both sides. I still show this step because I know a lot of learners forget about this and they just end up writing stuff like that. So this mistake is made because you leave out that middle step, okay? So I'm not going to always show that middle step. I'm going to show it for a while just so that we never make this mistake. Right, so x is equal to a positive 1. This should have been plus, so that's going to be a minus. Okay, great, we fix that. So now they ask for the coordinates, right? So we've got these two. Just show it to me in coordinate form. Obviously, B is going to be the one with the bigger x value, and then obviously A is going to be the one with the smaller one, the one that's on the left hand side. Great. So there we found out A and our B. Those are the x-intercepts. How do you find the x-intercept? Make y 0. So y 0, factorize, find your two solutions. They want the range of f. So range is all possible y values, right? So if I look at this and I draw, let's draw in a, this is horizontal line. If this horizontal line is shifted down, okay, when does it start touching my function? When does it stop touching my function? It starts to touch here at this D, right? If that horizontal line goes any lower than that D, then obviously it's not going to touch the function, okay? So range is y is an element. Where does it start? It starts by this y value of D, which is our n. Did we ever find n? We didn't find n. Let's go solve for n. And that's going to be where we start with our range. Okay, let's go do that. And then once we do that, we'll know it's from this point all the way up to positive infinity. I just want to get rid of those lines there. I don't want them there anymore. So we need n. So we are going to say f, and we have that 1. So this 1 is the x value I'm substituting into the function f. The 1 comes from there. So that 1 I'm taking and I'm putting in to f. My equation was x squared, so it's 1 squared minus 2 times 1 minus 3. 1 is still 1, minus 2 is minus 1, minus 3, so this is minus 4. So the coordinate we have is positive 1 and minus 4. So the minus 4 is our n value. So our range, y is an element from the minus 4 up until positive infinity. Infinity is never included. For us, that minus 4 touches the graph, so this needs to be included. I like interval notation, so I write it like this. If you want to say y is greater than or equal to minus 4, you're also good. This is the same thing. Right, let's see what next. They want us to find the average gradient between points B and C. Okay, so B is over there, C is over here. You're going to find average gradient, right? So you are going to, whenever you're finding average gradient, you make as if there's a line. So there's not a line here, but I'm making like there is one. Okay, so I'm making as if there's a line like that. And average gradient, you're finding the gradient of this pretend line. So we need coordinate C and coordinate B. We have coordinate B. We didn't find coordinate C. Coordinate C is the y value of the y-intercept. Okay, so let's go and say y-intercept of f. In order to find y-intercept, x must be 0. X must be 0. All right, so f of 0 is equal to 0 squared minus 2 times 0 minus our 3. So that coordinate is 0 and minus 3. This is the coordinate for C. So now I've got coordinate for B, coordinate for C. I'm going to go find the gradient of BC. So this is my average gradient, okay? Again, in order to find average gradient, you make as if there's a straight line there, and then you find the equation of that straight line. So we know the equation for gradient is y2 minus y1, x2 minus x1. And I'm going to do my substitutions now. Whenever I do the substitution, I'm going to make sure that I substitute an entire coordinate at the same time. So this coordinate C, I'm going to go put that whole thing in at the same time. I'm going to put the x at the bottom and the minus 3 on top. Then I've got minuses in the middle. The other coordinate, that's the coordinate for B, we have that one over here. So I'm going to take this coordinate and I'm going to substitute it in here. X goes at the bottom, so that's going to be a 3, and the 0 goes on top. That's over there. That's nice and easy. Next is to simplify. So minus 3 minus 0 is still minus 3. Minus 0, well, 0 minus 3 is still minus 3. So our gradient for our average gradient for BC is just a 1. That was easy enough. The video is already 5 minutes, so I'm going to cut it here. In the next video, I'll finish the question.